So I just got my hands on the Spec Exam 2. I haven't really heard how it was, to be honest, but we'll see how we go. Consider the statement that for the contrapositive. So the contrapositive is not that. So m is less than 5, n is less than 5. Implies not this. So m plus n is less than 9. Consider the function with that rule. Which of the following statements is correct? Function is continuous. So it depends. If this approaches infinity, probably not, but let's see. So x, 5, 2, and the negative would go over here. So it'll be x plus 5, x minus 2, and you'll see the x minus 2's cancel. So this is just the line x plus 5, but it's just not continuous at negative 2, but you end up filling it in with the same value that it was at 2. So it is continuous. The graph of f of x is equal to x minus h over that, and it will have no turning points. Right, so for no turning points, well, what we can do is we can solve the derivative of x minus h over x plus 1 times x minus 4 is equal to 0, comma x, and then what we can do is we can solve for this to be less than 0. Sorry, less than 0. So h is between negative 1 and 4, but we should also check what's going on at this, when this is 0. So in other words, when h is 1 or h is negative 1 or h is 4, because you'll notice that they're both positive h. So we're going to get the same solution for the derivative is equal to 0, same stationary point. It could just be an asymptote. Oh, no, what you'll notice is at negative 1, like if it is negative 1, this is 0, so the solution is x is equal to h, right? And if h was negative 1, but negative 1's an asymptote, so that's not part of it. And 4, same thing, so you're going to get 4 here, and 4 is an asymptote, so that's not part of it. So we should also include negative 1 and 4 in the values that will not have any turning points. Given that sine x is equal to a, then cos x over 2. So if we draw a triangle, that's x, a is here, 1's here, this is square root 1 minus a squared. It's in the fourth quadrant, so cos x is the square root, positive square root of 1 minus a squared. We know that cos x is equal to 2 cos squared x over 2 minus 1. So we can solve for cos. Now, is this going to be the positive or the negative root? Well, x over 2 is between 3 pi over 4 and pi. That's second quadrant, so we should give the negative square root. So let's solve. Menu 3(1) cos x, which was the square root of 1 minus a squared, is equal to 2 cos x squared minus 1 comma x. Okay, and it's the negative, so it's this one, which is the negative. So this, you can take out a square root, and then it will make over root 2 if you simplify that. So we don't care about that. It's just 1 plus square root, negative 1 plus square root, which is a. If the point there, so over here, is became this negative z conjugate. So the conjugate's here, and then negative would reflect in both axes, this and this. So it would end up over here, and that's just a reflection in the imaginary axis. A value of k that makes this purely imaginary. So what we can do is we can expand z squared plus 4i, this I, z, plus 3, but we know that z is 3 plus ki. Okay, so we want it to be purely imaginary, so that means that the real part is 0. And we get negative 6 or 2, but the only option there is 2. So it's a value. Alright, e to the x, okay, a solution to this differential equation. So that's e to the x times e to the negative y. And then this is cos x, cos y. So cos x, cos y plus sine x, sine y. And then cos x plus y, so minus that, is cos x, cos y. So it would be minus, but then we do a minus, minus, and plus. So it will end up being 2 sine x, sine y. Alright, so we can write that here. Now, so what we can do is we can move the y's over. So that will be 1 over e to the negative y, which is e to the y over sine y dy. And that should be equal to e to the x times 2 sine x dx. And if you integrate both sides. So that, no, that's got a negative here. It's only positive. So that's the answer. Consider the differential equation that we need to find the value of h here. To be honest, I can't be bothered solving for it, so what we're going to do is we're just going to try the answers. So we can do Euler. You put the differential equation, x times y squared, comma x, comma y, comma, in these squiggly brackets, the initial x is 0. The final x is x3, and that's going to be 0 plus h plus h plus h, so 3h. And then comma the initial y, which is 1, and then comma the step size, which is h. But at the end, we can say that h is equal to option A, which is 0.01. That's not the y value that we got. What about the next one? That's not the y value that we got. What about 0.20? 1.12658. Yes, that is what we got. So C will be the answer. The length of the curve, so the length of the curve is 0 to 2 pi square root of derivative, which is, that would end up being just sine squared, and then plus derivative of that squared, which is 1 minus cos squared. And to be honest, I can't really be bothered doing, so it's not that. Definitely doesn't look like that. It's probably A or C, A or D. To be honest, I can't be bothered doing the algebra, so what we'll just do is we'll just see which one's the same. So the integral that we had was 0 to 2 pi of square root sine t squared plus 1 minus cos t whole squared dt. That works out to be 8. Now what about option A? That's also A. So the answer is A. The curve defined by the parametric equations is rotated about the y-axis. So about the y-axis, it's going to be 2 pi x times the square root of dx over dt squared plus dy over dt squared. And that's going to be from 0 to k. So here if we do, I'm just going to enter this integral down, change it 0 to k. And then we've got 2 pi, and then x. Now x was 5t, and then times the square root of dx dt squared. Dx dt is 5, so 25, plus dy dt squared. Dy dt is 12, so 144, and that gives 65k squared. So that's A. The initial velocity of the particle is 40 meters to the east. How far in meters is it? 100. So this is velocity, this is time, and we want to know displacement. So I'm guessing this is east, and that's west. Okay, so how do we work out this area minus this area? Because this triangle is a bit weird. We can do the big triangle minus this trapezium, and that will end up subtracting this extra bit, but also this. Okay, so that big triangle is a half times the base, which is 100, times the height, which is 60. So that's 50 times 60, which is 30,000, minus this trapezium is a half times 100 plus 150 times the height, which is 20. And so that's 3,000 minus a half times 20 is 10, 10 times 1,500, 10 times 250, 2,500, which is 500. The position x meters of a particle moving along in a straight line from a fixed origin is given by that. The acceleration of the particle when x is equal to k plus 1. Okay, so the acceleration is just the derivative of that twice. So derivative with respect to t of e to the power of k minus 1 times t we want to know the acceleration when x is k plus 1. Okay, so first of all we can, actually I'll just leave that for now. What we can do is we can solve for t when x is k plus 1. So k plus 1 is equal to e to the power of k minus 1 times t, comma t. Okay, so what's this when t is that? K minus 1 squared times k plus 1. So that looks like none of the answers, but you'll notice that's k minus, so what was it? K minus 1 squared times k plus 1. Now this is k minus 1 times k minus 1 times k plus 1, and that's difference of perfect squares, so k squared minus 1, k minus 1. If the angle between the vectors is that, then the value of m is. So remember cos of theta, and that's theta, so it would just be 13 on 21 is equal to the dot product. So let's just do this on the calculator. So solve 13 on 21 is equal to the dot fraction, so the dot product of the first one is 2 comma negative 1 comma 2 comma the second one is 2 comma m comma 6, and on the bottom we have norm to the magnitude of this, times norm of this, comma m. So it says m is an element of real positive, so m is 3. Consider the vectors those where s is equal to that. If the vector resolute of r in the direction of s is equal to negative 4i plus whatever, then the scalar resolute. So the vector resolute of r in the direction of s is r dot r hat. Now basically this is r dot r over the magnitude, and then r over the magnitude. Now we know that this is just going to be r dot r what am I doing? The vector resolute of s in the direction r in the direction of s. So this should be s, not r. Okay, so it's going to be r dot s over now the magnitude of s squared, and then times by s. And that's okay. So this is gonna, what is that? So 4 plus 4 is 8 plus 1 is 9. So that's 9. And that's equal to we just want this, right? So this is just a constant. No, so yeah, we just want that. So it's going to be so we don't want that anymore, and we can divide it by so we just need to figure out what so they told us s, and what number do we multiply to get this? Well, it looks like negative 18, so negative 18 would make that negative 36 plus 36 minus 18. Yeah. The position of a moving body is given by that, where t is measured in seconds. The motion of the body can be described as moving along a parabolic path given by. Okay, so this is sine t, and this is 1 minus 2 sine squared t, and so y is 1 minus 2x squared, so not that. The starting point is x is 0 and y is 1, so starting at 0, 1, so that's fine. Reversing direction, so we need to figure out where it reverses direction, or in other words, when the velocity is 0. Wait, can we use the other point to distinguish between the two? No, we can't. Oh, so here we can use after pi seconds or 2 pi seconds. So it should return back after 2 pi seconds, because returning to 0, 1, whoops. Okay, let's just plug in pi, right? That's 0. That's 0. It's going to be at pi. I think it's C, but let's just double check where it reverses direction. So that's when the velocity is 0. So cos t is equal to 0, and 2 cos 2t. Wait. So it starts here and it just goes that way, right? What's 1, negative 1? That's over here. I think it's just C, because it will return to 0, 1 after pi seconds, because the period of this is pi. Particle 1 has a position vector that, and particle 2 has a position vector that, where t is measured in seconds. The number of times the velocity of particle 1 is perpendicular to the position vector. So particle 1 has that, the number of times the velocity of this, okay, so the velocity is negative sine ti plus cos tj plus whatever the derivative of that is. I'm just going to say r dot t is perpendicular to the position vector of that. So dot r2 of t is equal to 0. So what we can do is we can just store store cos t, comma, sine t, comma, square root sine 2t as R1, and then the next one is sine t, cos t, and then square root of sine 2t as R2. And we want to know when the dot product of the derivative of R1, comma, R2 is equal to 0 from 0 to pi over 2. Once. Okay. Consider the following parallel lines. The shortest distance between L1 and L2 is. Okay, so if this is L1 and this is L2, any point on this is 1 plus s, 3 plus s, and 1 plus s again. And any point on this is negative 2 plus t, and then 1 plus t, and then 3 plus t. Okay, so we want this minus this to be perpendicular to that, and then find the magnitude of that. So what is the, if we subtract these two, one plus s, comma, 3 plus s, comma, 1 plus s, minus negative 2 plus t, comma, 1 plus t, comma, 3 plus t. Okay, so that's that. Now we can just let s minus t be like, I don't know, m, like something else. So we want to solve the dot product of this, but we can just let this be something new because it's just another parameter. So just say q, and the direction vector of the thing, which is 1, 1, 1, is equal to 0, comma q. So q is negative 1, and we want the magnitude of that vector when q is negative 1. So norm of this when q is negative 1, which is root 14. The point of intersection of that line and the plane is. So what we can do is we can plug in all of those things. So we can do a solve, and we've got 3 times x. Now what's x? X is 1 minus 2t minus 2y. Now what's y? Y is 1 plus t, and then plus 4z. Now what's z? Z is negative 2 plus 3t, and that should be equal to 5. So t is 3, and so the point is that when t is 3, so 1 minus 6 is negative 5. The middle one is 4, so option D, negative 5, 4. And then we can just check the last one, should be 7. Negative 2 plus 9 is 7. When conducting a hypothesis test, a type 2 error occurs when. So type 2 is when you don't reject when the alternative is true. So you should have rejected, but you didn't. The masses of avocados in a crop may be assumed to be normally distributed with a mean of them. After an avocado of that is peeled and the stone is removed, the mass of edible flesh is given by that. 4 avocados are randomly selected from the crop. What's the probability correct to 4 decimal places that a total of more than 570 grams of edible flesh is obtained? Okay, so what's the normal distribution for F? Well, E of 0.70m is 0.7 times the mean, which is 140. And the standard deviation, so that's 7.5 squared is the variance, but we multiply by 0.7 squared to get the variance. So 0.7 squared times 0.75 squared, that's the new variance, and if we square root that, then that's the standard deviation, 21 on 40. And we want to know the probability that a total of more than 570 grams of edible for 4 avocados. So that would be 140 times 4. So keep in mind that's N4, not A, like A4. So that's the mean, and the standard deviation, remember, it's just going to be the variance plus the variance plus the variance, but 4 times again. So just be careful that the variance is 4 times that, and it should be the square root squared. So what's the variance? 4 times 21 on 40 squared is that, and then the square root of that is that. So 21 on 20 is the standard deviation. Okay, and then we want to know that it's total of more than 570 grams. So menu 552, 570 up till infinity. The mean is 140 times 4. The standard deviation is 21 on 20. And, oh, what's that? I got something pretty bad. That's 560, isn't it? And I think I must have done something wrong there. So 0.7 squared times that. Oh, that's what I did. I did 0.75, but it's 7.5 for some reason. Okay, so it's that. Now what else did I do? And then we should multiply that by 4. And then square root of that is the okay, 0.1705. Okay, so that's the multiple choice. Consider that function, sketch the graph, label the vertical asymptotes, and label the stationary points with their coordinates. So what we can do is we can go to the graphing page. I'll probably just define it first, actually. So f of x define as x to the power of 4 minus x squared plus 1 over 1 minus x squared. And then we can sketch it. Okay, so where our asymptotes will be at +1 and -1. So what I'll do is, you should probably do this as well, you should just make your window the exact same as what they've given you in the question. So in the question it goes from -2 to 2, I'll go, I don't know, -2.5 to 2.5. And the y values, the scale will make it go up by like 0.2. And the y values go from basically -10 to 10. So I'll go -10 11 to 11, and the scale is by 1. So this is basically what you want to sketch, right? So the stationary point here is at the 0, 1. And you've got your asymptotes at x is equal to -1. And x is equal to +1. And then it just kind of goes like this. It's a bit fatter on this side. And then what other asymptotes do we have? We have an asymptote here, but that's the functional asymptote. So what you can do is you can expand f of x, and it should be a y is equal to -x² asymptote, I think. Is that right? Yeah, I think it is. So -x² will go -2 and 4, right? So it'll be like there, and then there. So it'll be like that, and then -2 and -4 here. So that's your other asymptote, and then you've basically got this. Now, don't think these are stationary points, but I'm just going to label them just in case. So that's root 3 minus 1 -3, and this one here is, sorry, it should go through 3. Negative root 3 minus 1 -3. Oops, I think I solved the wrong value. Oh, it's just -√2 and +√2. Okay. The region bounded by the graph of y is equal to f of x, the lines y is equal to 1 and y is equal to 6. So this is rotated about the y-axis to form a solid of revolution. Write down a definite integral involving only the variable y that, when evaluated, will give the volume of the solid of revolution. So it's pi times x² dy. So 0, sorry, not 0, it's going to be 1 up until 6. And it's going to be, if we solve for x squared, so we can do y is equal to f of x. Oh, that's probably a bit annoying. So what we can do, because you'll see there's x squared everywhere, you can basically say that this is, you're solving for y is equal to, now here it's going to be x squared minus x plus 1 over 1 minus x, where x is x squared, if you imagine that. And you want to solve for x because x is x squared. So what you can give is you just have to give one of them, and it'll be this one, which is square root of y squared plus 2y minus 3 minus y plus 1 all over 2 dy, I think. Yeah. Okay. And then find the volume of the solid. So we want pi times the integral from 1 to 6 of this dy. It's 11.2. Okay. Now consider a function with that rule. For what value of the graph for what value b will the graph of g have no asymptotes? So no asymptotes. Okay, wait, let's just expand that. No asymptotes. Okay, so if b is x plus 1, wait, no, if that's 0, if b is 0, you won't have that, and that, okay, so you want all of this to be equal to 0. Wait. Or actually no, because you can't have b 0, because then you'll still have this part, but you'll know that this is the same as this and this is the same as this. So what you can say is if b is -1, then this part minus this part will be, so it'll be that part minus that, which is 0, and negative that plus that, which is 0. So b is -1. The gradient of the function is given by that. For what values of b will the graph have exactly one stationary point? Okay, so one stationary point, we can solve the derivative is equal to 0. Wait, let's just... Yeah, that's what they've given us. I'm just going to write what they've given. So solve -2x times x squared minus 1 squared minus b plus 1 over, well, that should be over around the whole thing, over 1 minus x squared squared. Oops. We want that to have to be equal to 0, comma x. We'll have one stationary point. Okay, so that's that. Now this can be equal to 0, or this can be undefined. Okay, wait. So this is equal to 0, comma b. It doesn't work. This is the same, it won't work. What about this? 1 minus, now maybe we can solve that. B is equal to 0. Now if b is 0, what's that? That's going to have an extra one. So we just want this to be undefined, that root b plus 1 to be undefined. Because even if this one of them is 0, the other ones, like this one for example, is going to be square root 2, right? And that's an extra one. So one stationary point would just be when this is less than 0. Three stationary points. Okay. So for 3, I think that's what we just worked out. So that's when b is 0, because here, what will we have? So we'll have the 0. We'll have these two are 0, right? So that would be the 1 minus ones. So that one will be 0, that one will be 0. But then we'll have a negative square root 2 and a positive square root 2. So that would be 3. Right? So b is equal to 0. I'm just trying to see if there's another case. So if x is 0, that's definitely one of them. Then the other one, the other case is if this is equal to that, right? Is that right? Let's just see. So if b is negative 1, then what are our solutions? Just one. Oh, because we only have... Okay, so I think it's just b is equal to 0 for that one. And then for 5 stationary points, I think we have to... This is kind of like the methods exam. We have to say not... Yeah, we have to say not 0, not negative 1, not less than negative 1, but also not including negative 1, because including negative 1 will also just have 1, as we just saw. That's my guess. So b is an element of... So for 5 to infinity, it's going to be negative 1 to infinity, not including negative 1, and not including 0, I think. So that shouldn't be included. Okay, let's just do a slider just to make sure. So we can draw the derivative. So I'm going to get rid of this. And I'm going to instead draw the derivative and see how many x-intercepts it has. Oh, it was g of x, whoops. G of x was x to the 4 plus b over 1 minus x squared. Okay, so when b is 1, we've got 1, 2, 3 x-intercepts. Which... Wait. So is 1 another one? Yeah, 1 is another one. So I'm going to add that to here. And then here, excluding 0 and 1. Okay, let's go back here. Now, if we go down to 0, that's again 3. What about negative 1? Negative 1 is just 1, so as we said, we can't have that for 5. 1 stationary point. Oh, and so b is less than or equal to negative 1, because that's another stationary point. And then if we go down here, negative 2, there's also just the 1. Okay, what about if we go to positive like 2? We still only have 3, unless that comes back and touches. No. There's still only 3. So I think for 3 stationary points, it's b. I think I've swapped them around. What's b is 0? So 0 gives 3. 1 gives 3. Basically everything in between gives. 3. Okay, so then this one should be the -1 to infinity, including 0 and 1. But I think excluding, yeah, so -1 to infinity, and that's excluding the, okay, well what about the 5? When do we have the 5? So that's basically when all of these are different, but they're all real. Where was it? Here. Now when are these different? So that's different when this, so this has to be positive, right? I'll just change this to A. So that's between -1 and 0. So I think that's the rest. Let's just check. So if I did like -0.5. Oops. Yeah, 1, 2, 3, 4, 5. And then let me just change my step size. So control menu. Let's just say 0.1. Okay, so yeah, so between 0 and 1. Okay, -1 and 0. And -1 wasn't included. That's pretty hard. Okay, let's move on. I think I spent too long on that. Express the relation in the form y is equal to mx plus c, z is equal to x plus iy, z is equal to 1 plus 2i, z2 is equal to 4. Okay, so we've got z minus, so this is the perpendicular bisector of 1, 2 and 4, 0. Now the gradient of that is -2 over 3, so it should be have a gradient of 3 over 2, and then the point that's on it is the midpoint, so it will be 3 over 2 and then 1. So y minus 1 is equal to 3 over 2, x minus 3 over 2, I think. And if I just solve, that's y is equal to 3x over 2 minus 5 over 4. Right? The line segment from that is the diameter of a circle. Find the equation of this circle in the form that. Okay, so we've got the points 1, 2 and 4, 0, and that's the diameter of a circle. Okay, so what's the radius of this circle? Well, the radius is going to be half of the distance between 1, 2 and 4. So that's going to be 3 squared plus 2 squared. So that would be root 13 on 2. Sorry, that's 2 squared, not 4 squared. And then the point, the center, is the midpoint. And the midpoint is we just did it. It's 3/2, 1. So therefore, z minus 3/2 minus I is equal to root 13/2. The second circle is given by that. Sketch this circle. So this has a center of 1, 2, and a radius of 2. Give me a circle. There we go. Labeling the imaginary axis intercept. So 1, 0. Oh, the imaginary axis intercept. Seriously? Okay, so this is x minus 1 squared plus y minus 2 squared is equal to 4. And so the imaginary axis intercept is y minus 2 squared is equal to 3. And y is equal to 2 plus or minus root 3. So this is 0, 2 plus root 3. This is 0, 2 minus root 3. Array originating at the point 2, negative I. So 2, negative I, that's over here. Passes through the point negative 2 plus 3i. Cutting the second circle. Sketch that ray. Okay. Done that. Find the equation of this ray. So it's definitely arg z minus z0. So it originates at that. So minus 2 plus I. And the theta, so we can find the gradient of this line. So this is 2, negative 1. And this is negative 2, 3. So what's the gradient? The gradient is 3 plus 1 is 4 over negative 2 minus 2. So the gradient is 1, isn't it? So it will be 3 pi over 4. Yeah? That looks about right. Find the area of the minor segment formed by the intersection of the ray and the circle. So this is 90 degrees. So it's going to be a half pi over 2 minus sine pi over 2. A half r squared, and r squared is 4. Which is 2 times pi over 2 minus 1, which is pi minus 2 units squared. Is that right? Yeah, I think so. A pollutant at time t is equal to 0 days begins to enter a pond of still unpolluted water at a rate of that, where V is the volume of pollutant in cubic meters in the pond after t days. The pollutant does not dissolve or mix and spreads across the pond, maintaining the shape of a thin circular disc of radius r of t meters and a constant depth of 1 millimeter. What is the maximum rate in cubic meters per day at which the pollutant will enter the pond, and for what value of t will this rate occur? So the maximum occurs for the smallest value of t. because the smaller the denominator, the bigger that will be. So, but that's at t is 0. Let's just, we can even just sketch it. So if we go here, get rid of all of this, and just sketch 8t, we have to use x here, because it's the calculator, over 240 plus 5x squared, x to the power of 4, whoops. So what's the maximum rate? I think my thing stuffed up. Okay, so the maximum's over here. So it happens at t is 2, and it looks like 0.05. Let's just double check. Yeah. Okay. At what rate is the radius of the disk increasing after t is equal to 4 days, where it may be assumed that the radius of the disk is 6.54 meters? Give your answer in meters per day. So we want to know dr over dt when t is 4 and r is that. So if this is dv dt, so that's dr over dv times dv over dt. Now dr over dv, so what's dv dr? So this is looks like that, I think, and that's got a height of 1. So pi r squared h is the volume, and that's just pi r squared. So dv over dr is 2 pi r. And so dr over dt is 1 over 2 pi r times dv dt. And then you plug in t is 4. And, oh wait, this is 6.54 meters, yep. And r is 6.54. So what's dr dt? 1 over 2 pi times r, which is 6.54, times 8t over 240 plus 5t to the power of 4, but t is equal to 4. So the answer corrected 2 decimal places. I must have made a mistake. Oh, give your answer in meters per day. Oh, this is in millimeters. That's pretty tough. Oh no, that's a depth of 1 millimeter. So the depth, so the volume is actually, so how many meters is, so 1 millimeter is 0.1 centimeters, and then 1 centimeter is 0.01, yeah. So I think it's 0.001, yeah. is the height in terms of meters. So yeah, let's just check my conversions right. So if I want to convert that to centimeters, I multiply by 100, 0.1 centimeters, and then to convert to millimeters, that's 1 millimeter. Okay, so what is that? So we know that V is pi r squared times 0.001. dV over dr is 0.002 pi r. And then what else do I need to... So that's in meters, the radius, and the radius is in meters. Okay, so I think all I need to do is just fix that up by changing the decimal place, but let's just see. So that's 0.002. So to 2 decimal places, that's 0.51. That's tricky. Use the suitable substitution u is equal to root 5t squared to express that as an integral involving only the variable u. Okay, so u is root 5t squared, du is 2 root 5t dt. Now that's 2 root 5t if I put 4 on the outside and then over root 5, right? Because this multiplies still to be 8t. Okay, so that's the du that we needed. Now for this, 5, if we square both sides, u squared is 5t to the power of 4. Okay, so it will be 4 over root 5 integral of 1 on 240 plus u squared du. Hence, or otherwise, find in terms of T the total volume of pollutant that has entered the pond after T days. Give your answer in the form 1 on A root B. Okay, so what we need in this integral, this is the tan inverse. We need A here, where this is A squared. Sorry, no, we don't. That's fine. Let me just double check. Well, what we can do is we can just use the calculator. One on 240 plus u squared du. Okay, so that's root 3 on 15, 10 arctan of 15 root 15 u over 60. Now just be careful, yeah, they want to over 1 over something. Now remember, 1 on root 3 is root 3 on 3. We've got that, but if we just write that as 5 times 3. So that's 1 on root 3, so it should be 1 on 5 root 3. Now that will work out to root 3 on 15. Arc10. Now again, we've got root 15 over 60, which is 1 on root 15 times 4, I think. Wait, so this is root 15 on, wait, that's 15 times 4, and then root 15 on 15 is 1, yeah, so 1 on 4 root 15 u. And what's u? U is root 5t squared. And this can make root 3 on the denominator. Now it should be a plus c, and then I think the constant will be 0. So what's the initial? The initial volume is 0. And then if you plug 0 here, it's 0. Yeah, I think that's right. Yeah, and that b is the same. Nice. What surface area of the pond would the coverage of the pollutant approach? So the total volume of pollutant that has entered the pond after t days. So the surface area what's this? This is a so I think the volume what's the surface area? The surface area of the pond is, does that include this? Well, not really, because that's just depth. The surface area is just the top. That's the surface of the pond. So that's going to be 2 pi r. But do we have r in terms of t? Or we can figure out that when t approaches infinity, remember that's an arctan. Now arctan goes to pi over 2. So v goes to 1 on 5 root 3 times pi over 2, which is what? Oh, I wasn't even sharing my screen that whole time. Whoops. 1 on 5 root 3 times pi over 2. So that's the volume as t approaches infinity. Goes to 0.18138. Now that means that the radius goes to, what does the radius go to? So we can solve, remember the radius, so it was 0.001 times pi r squared is equal to 0 this comma r. Okay, so the radius goes to that. Now what does the surface area go to? It goes to 2 times pi times that. 47.74. That's got to be wrong. I think that might be wrong, but whatever. The cleanup of the pond begins after 5 days, where the pollutant is removed at a constant rate of 0.05 cubic meters per day until the pond is free of pollutant. However, efforts to stem the flow are unsuccessful and the pollutant continues to enter the pond. After how many days from the start will the pond be free of pollutant? So now what have we got? We've got dv over dt of pollutant is 8t over 240 plus 5t to the power of 4 minus 0.05 t. No, just 0.05. And then we want to know after how many days will it be free of pollutant. So in other words, the integral from the initial time until the time until a certain time of this is equal to 0. What have I done wrong? So we want to know when the volume is equal to 0. Now that's the dv dt. It's in at that and out at that. It's not t, is it? No. I think we've got to put, do we have to plus the initial volume at the end? The initial volume after 5 days, so 1 on 5 root 3 arc10 25 over 4 root 3. So that's the initial volume. So do I add that on at the end? And then I subtract 5 from that. Because it's how long after the thing started. So 3 point. So this here should be plus 0.15 0.2, and then A is equal to 8.401. Therefore, time after 5 days is equal to 3.401. To 1 decimal place, 3.4. Oh, man, I think I messed up this question. It's okay. A model yacht is sailing on a lake between two buoys. Its path from one buoy to the other relative to an origin O is given by that. Displacement components are measured in meters. Using a trigonometric identity, show that Cartesian equation of this path is given by that. So we know that sec squared t minus tan squared t is equal to 1. So x is equal to 3 sec t. So x squared on 9 is equal to sec squared t. Y is equal to 2 tan t. So y squared over 4 is equal to tan squared t. So we've got, therefore, x squared on 9 minus y squared on 4 is equal to sec squared t minus tan squared t. Therefore, x squared on 9 minus y squared on 4 is equal to 1. Sketch the path of the yacht. So this is a hyperbola. Label the endpoints with their coordinates and show the direction of motion. But t is only between 2 pi over 3 and 4 pi over 3. So, what's 3 sec of 2 pi over 3? So the initial x is negative 6. So over here. And the initial y, 2 tan of 2 pi over 3, is negative 2 root 3. So negative 6 and negative 2 root 3, that's like, what's that approximately? Negative 3.46, so 3 point, almost here, okay? And then, oh, whoops, over here. So that endpoint is negative 6, negative 2 root 3. And then at 4 pi over 3, again, it's negative 6, but I think it'll probably be positive 2 root 3. And then I think it goes like that. Just need to get the vertex. So the vertex is just going to be at the origin, isn't it? No, that's where they intersect. So it'll be the thing plus 3. So it will be here. I think that's right. Write down an expression in terms of sec t for the square of the speed of the yacht at any time. So the speed is, it's the derivative of, okay, so it's the square root, but we don't need the square root because we want squared, and it's the derivative of 3 sec t squared plus the derivative, that should be dt, of 2 tan t all squared. Is that right? So the derivative of that and then the magnitude and you square it. So 9 sine squared t plus 4 over cos to the 4 of t. Find the time in minutes when the minimum speed occurs. You do not need to justify that this speed is a minimum. So when does the minimum speed occur? Well, it's between 2 pi over 3 and 4 pi over 3. So I'm just going to sketch this speed. So 9 sine x squared plus 4 over cos x to the power of 4, but 2 pi over 3 is less than or equal to x, which is less than or equal to 4 pi over 3. And the minimum speed occurs it seems like it's just when it's pi. And that makes sense, because that's when cos is a maximum. State the minimum speed of the yacht in meters per minute. And that would just be the 4. That was the y coordinate. State the coordinates of the yacht when the minimum speed occurs. Sec of pi is -1. Just make sure so I don't make a silly mistake. -3, and then 2 tan of pi is 0, so -3, 0. Write down a definite integral that gives the distance travelled by the yacht along the path over the time interval. So the integral from 2 pi over 3 to 4 pi over 3 of the square root of dx dt squared which is, can I just write r dot? Well, I'll just write it. So it was 3 sec t, so I'll just write okay, and find the distance travelled by the yacht over this time. So 2 pi over 3 to 4 pi over 3 of the square root of the derivative, so of sec 3 sec t. I'm pretty sure that's just the speed part, but it doesn't matter. Plus the derivative of 2 tan t all squared to 1 decimal place, so 9.4. The position vector of a drone videoing the yacht relative to the same origin as the yacht is given by that. Displacement components are measured in meters and time is measured in minutes. What is the shortest distance from the drone to the yacht as the yacht sails along the path given by that? So what we can do is we can do RD minus RY, the magnitude of that, and find the minimum. So let me just define. So RD is 2 minus 3t, comma, 4t minus 1, comma, 6 minus t. That's RD. And then 3 sec t and then 2 tan t and then 0 for the k component. That's Ry. Now if we do the norm of RD minus ry, we get this thing, which is ridiculous. I'm just going to write in my working out d over dt of rd minus ry is equal to 0. So here, what's the intersection between the two domains? So what's 4 pi over 3? 4.188. So I think we go from 2 pi over, it's just a 2 pi over 3 to 4 pi over 3. Because the other one is 0 to 5. So t is 2.34 or t is 3.87. Now what's the distance for each of these? So the minimum happens at 11.07. .0. So when that's 0, what about if I did it from 0 to 5? Well, we can't because it's not defined. The other one's not defined. Yeah, I don't think that works. I think we have to use this one. Like the one we had before. We can't use this. Oops. Whatever. Yeah, that doesn't even work. Okay, find the vector equation in terms of the components I, j, and k for the line passing through these points. So the direction vector is going to be b minus a, and the point is just a. So it's going to be L is equal to I minus 2j plus 3k plus t and then 2 minus 1 is I, negative 5 plus 2 is negative 3, and then negative 1 minus 3 is negative 4. Consider the different line that, find the shortest distance from L1 to point A. Give your answer in that form. So we've got this line. And then any point on here is 2 minus t, 1 plus 2t, and then negative 3 plus t. And then this point A is 1, negative 2, 3. So the shortest distance is going to be when that's perpendicular. So if this is A and this is P, so in other words, AP dot the D, the direction vector, which is negative I plus 2j plus k is equal to 0. So what's AP? Well, we can just do that on the calculator. So 1 I don't think we need to do that on the calculator. 1 minus 2, AP, sorry, is P minus A. So it will be 2 minus 1, which is 1 minus T I, plus, now 1 plus 2t minus 2 is negative 1 plus 2t j plus negative 3 minus 3 is negative 6 plus t k. And so that should go there. And therefore t is equal to what? So if we do a solve, dot product of 1 minus t, comma, negative 1 plus 2t, comma, negative 6 plus t, and then comma, the direction vector, which is negative 1, comma 2, comma 1. That should be equal to 0, comma t. I think I typed something wrong. Negative 6 plus t, not negative 6 plus 6. Is that right? And then if I do the norm of this vector, I don't think that's right because B and C are different. Let me just do, so let me make sure I've done that right. So 2 minus t, and then 1 plus 2t, and then negative 3 plus t, and then let me do 2 minus t, comma, 1 plus 2t, comma, negative 3 plus t, minus 1 comma negative 2 comma 3. Okay, I definitely made a mistake. So it's 1 minus t, negative 1 plus 2t. I wrote negative 1 plus 2t, but it's 2t plus 3. And then t minus 6, which we did. So I think the middle one I stuffed up. Now, the norm, oh wait, we've got to do the solve first. So the dot product of this, but the correct one, t is 1/6, and then this, when t is 1/6, oops, the norm of that. Is that. Alright, let C be the point 0, 2, negative 5. Find the Cartesian equation of the plane that contains the points A, B, and C. So, we've got A, B, and C. Then we can say BA and BC are normal to those vectors. So, BA. Now, let me just define A, B, and C so I don't make any more mistakes. So A is 1, comma, -2, comma 3. Store that as A. B is 2, comma, -5, comma, -1. Oops, need to store that. And C is, what is it? 0 to -5. Okay, so we want the cross P of B, so A minus B, comma, C minus B. And that's -40, -12, -1. And so what we can say is we can say dot P of x comma y comma z comma the normal vector is equal to a point this should be on the outside. Okay, so I'll just write some more working out because it's 3 marks. So I already said that's n. Okay, so that means that -40 x minus 12y minus z is equal to -19. 40 x plus 12y plus z is equal to 19. Another plane has the Cartesian equation that the plane intersects the coordinate axis at 3 points which form the vertices of a triangle. Find the coordinates of these 3 points. So first of all, we've got 0, 0, 6, so 6, 0, 0. Next we've got 0, -4, comma 0, right? So yeah, and then we've got 0, 0, 3. All right, now find the area of the triangle. So so if this is point like A, B, C, then what we can do is we can do the half of the magnitude of the cross product of BA cross BC. Okay, so we've got half. So let me just change my A, B, and C. So if I say A is 6, 0, 0, B is 0, -4, 0, and C is 0, 0, 3, then we can say a half times norm of the cross P of A minus B, comma, C minus B. Oops, that's a comma. So 3√29. Okay, last question. A machine fills bottles with olive oil. The volume of olive oil dispensed into each bottle may be assumed to be normally distributed with a mean mu and standard deviation of 4.2. When the machine is working properly, mu is 1000. The volume dispensed is monitored regularly by taking a random sample of 9 bottles and finding the mean volume dispensed. The machine will be paused and adjusted if the mean volume of olive oil in the 9 bottles is significantly less than 1000 at the 5% level of significance. When checked, a random sample of 9 bottles gave a mean of 997.5. A one-sided statistical test is to be formed. Write down a suitable null alternative hypothesis. So the null hypothesis is that the mean is equal to 1000. And the alternative hypothesis is that the mean is less than 1000. Find the p-value for this test, correct to 3 decimal places. So the p-value is the probability that the x-bar is less than 997.5 given that the mean is equal to 1000. Okay, so menu 552, negative infinity to 997.5, and the mean is 1000, and the standard deviation is 4.2 over square root 3, square root 9, 4.2 over 3. Which is 0.037. Using the p-value, state with a reason why the machine should be paused. Since p is less than 0.05, the machine should be paused. Assuming that the mean volume dispensed by the machine each time is in fact 997 milliliters and not 1000, find the probability of a type 2 error for the test using 9 bottles at the 5% level of significance. Assume that the population standard deviation is 4.2 and give your answer correct to 2 decimal places. So we need to find the critical value. So that's XC. So that would be less than, the x bar is less than the x bar critical, given that the mean is 1000. So that's the last value that we would accept. So if we do an inverse normal, the area is 0.05, the mean is 1000, and the standard deviation is 4.2 over 3. So the last value we would accept is 997.697. Now we want, if we do a type 2 error, we didn't reject it. So probability that x bar is greater than 997.697, and given that the mean is actually, so we should have rejected it, given that the mean is 997. So that's the working out. Menu 552, 97.697 to infinity. The mean is 997 and the standard deviation is 4.2 divided by 3. So 0.31. I'm just gonna make sure I use a better approximation. So yeah, still 0.31. Let x bar denote the sample mean of a random sample of 9 bottles. As a quality controlled measure, the machine will be paused if x bar is less than a, or if x bar is greater than b, where x is So find the values of A and B. Okay, so again we can do an inverse normal. The area is 0.01. The mean is 1000. The standard deviation is 4.2 over 3. And so A is 996.7 and B, so we would just put 0.99 here. And so that's 1003.3. A new machine is purchased and it is observed that the volume dispensed by the new machine in 50 randomly chosen bottles provides a sample mean of 1005 and a sample standard deviation of 4. Find 95% confidence interval for the population mean volume dispensed by the new machine. Giving values correct to one decimal place, you may assume a population standard deviation of 4. So we've got the sample mean minus 1.96 times the square root, times the standard deviation of 4 over square root 50. So what's that? $1,003.9 until $1,006.1. 40 samples, each consisting of 50 random chosen bottles, are taken, and a 95% confidence interval is calculated for each sample. In how many of these confidence intervals will the population mean volume dispensed? So it should be in 95% of them, right? So what's 95% of 50, of 40? So 38. What minimum size sample should be used so that with a 95% confidence the sample mean is within 1 milliliter of the population mean volume dispensed by the new machine? So that the sample mean is within 1 milliliter of the population mean volume. What's the population mean? $1,000? Or is it that? What minimum size sample should be used so that with 95% confidence the sample mean is within 1 milliliter of the population mean volume dispensed by the new machine. So what's the population mean? The population mean is right? No. So is it just 16? I think it's just 16 because then it's 1 away. Because that will be 4 over 4 minus 1 plus 1. But then if you go bigger, it would be even better. And it's within 1 milliliter. So that includes 1 as well. Right? I think so. To be honest, that was an okay exam. I think I messed up the differential equations question, but overall it wasn't so bad. Let's just double check. Yeah, I think from here I messed it up. I think these two parts, but doesn't matter. I hope everyone went well. And yeah, that's it for maths for you guys, so congrats.